Hi everyone, welcome back to our YouTube channel Sid Education. In our today's video, we are going to derive time complexity of quicksort. So when I talk about quicksort, let me give a brief introduction again. That quicksort works on the principle called as partition. It is also work on the methodology called as divide and conquer, right? So if you have seen our previous video where we have discussed how the algorithm look like. So we have seen that what we do, we basically check for pivot is greater than a of I, where I is your low. We consider low, initialize I as low. And if it is true, we increment I. If it is false, we check whether pivot is less than a of j. If this is true, we decrement j. And if it is not, we do a swap based on condition that I is less than j, then you will do a of I and a of j. If not, you are going to do pivot with a of j, right? So basically, if you have remember, if this is my problem set, I used to consider my first element as pivot. Again, pivot can be any element, can be first, can be last, can be middle, or can be a random element. But I used to consider first element as pivot. So, according to quicksort, this pivot used to figure it out its position. For example, if this is the position of this pivot, I'm just guessing. So, now we have two sub problems to solve. Sub problems to solve. Now, this is sorted. This is at the right position. Now, we need to figure it out on these things. That is why we used to call it as divide and conquer. Divide and conquer means this problem is now divided into two subparts. Now again, this will be divided into some parts, right? And we are going to do that, right? So when we talk about the time complexity, so time complexity here will have three different cases. That is the first one, best case. Second is average case. And third is worst case. So in our this video, we are going to discuss about best case and average case time complexity, and we are going to derive it. The reason is it is same for both these cases. Now let me tell you why it is so and when we say the time complexity will be best and when it will be the average, when these cases occurs, right? When I talk about the best case, right? So best case is like when your whole array is divided, if this is n, it is divided exactly into two halves. The problem is divided into exactly n by two halves because of the pivot. So best case occurs, you can write when pivot element divides the array into two equal halves, right? For example, I have four elements, okay, or I have, okay, now that four element, if I do that, if I have taken this as pivot, I am left with three elements. Now this pivot came here, one, two, let's say, I'm just guessing it, right? So reason here is, now one side is already sorted, because if something comes here, and I'm guessing the two elements will come right to it, right to the pivot. Now I want to only tackle this, right? So this is again, so this is not the best case, but it's an average case, right? Average case. Average case means here the pivot divides into two parts. So you are getting division of two parts, but not necessarily that they are equal. That is why the time complexity for best case and average case remain same, right? If I have five elements, so first element is pivot. So after pivot, now you apply the quicksort again on these two element subarrays and you will get this sorted, right? That's the best case. Average case is this kind of thing where There is a randomly, some of them may be sorted, may not be sorted. So you get the two parts, but not equal, right? Though I want to talk worst case in our next video, but I will give an idea. What do you think the worst case here? Do you think it will be a sorted array? If you have given a sorted array and you apply, see, that depends, right? For example, if I'm considering first element as pivot, in that case, worst case is reverse order sorted array. I'll give an example. Let's say 4, 5, 3, 2, 1. Now I want to sort this array using first element as pivot. Now, according to quicksort, this will take the position here, right? So you will be left with 1, 2, 3, 4 elements. Now you need to tackle these 4 element array. So basically your problem size was n. Now your problem size in next iteration is n minus 1. Whereas in best case, either it is reducing to n minus 2 or somewhere, if you see here, somewhere to 1 or somewhere to more than n by 2. Somewhere here in this range, right? So that is why it's a worst case. Now if you are considering last element as pivot, in that case normal sorted array will be the problem. If you're considering this as pivot, because this remains at this position only, then again you need to check for these problem. So your problem size is reducing to n minus 1 in that case. So next will be n minus 2, next will be n minus 3. Are you getting it? Whereas here it is dividing. In the best case and average case, it is getting divided. If you understand this, so let's get started with the derivation. Okay. So for best case and the average, it follows same for that, right? So consider, let's say my n is 1, that is only I have only one element. If I have only one element, so if I'm considering t of n is the time taken for quicksort. So what do you think? If only one element is there, let's say if it is 4 is there, so it will take only a unit time because it is already sorted, right? One element is sorted, so t of n is 1 when n is equals to 1. Now, if n is greater than 1, second condition, then you see what we were doing, we were dividing the array into two parts, right? N by 2, n by 2, right? So t of n becomes 2 times t n by 2 plus n. Now let's analyze this, right? This 2 is because we are dividing the array into two parts. Array into two parts. This n by 2 is that each subparts, element of each subparts array has n by 2 elements, right? And why this n? Because how many comparison you will make? At least n comparison you are going to make. So only difference in average case gonna be about this. That's why time complexity for best and average case remains same. I can derive for the average case also, but there is no point because I told you, right? I told you there will be again, you will get the partitions, but they won't be of equal size. So asymptotically dominance, you will get it from best case only. Are you getting it? Okay. Now let's get started. So this is on the first run. Now if we again divide the array, what you will get? So now you put instead of n, you put n by 2. If you put instead of n, now again you will divide it, right? So what you will get? You will get 2. Now tn by 2 follow this principle. So instead of n, you put n by 2. That is 2t n by 2 by 2 plus n by 2. Okay. So this is what I have written, right? Plus n was already there. So this t of n by 2 I have got from this, because t of n was t, instead of t of n I have to write 2t n by 2 plus n. So instead of t n by 2, what I will write? I will write 2t n by 2 plus n by 2. So if this tn is this, tn by looks like this, and that only I have put it here. I hope this is clear to you. Now let's divide one more time. So if you divide one more time, what you will get? Okay, or if you want to simplify, you can simplify, there's nothing wrong. So this becomes 2 to the 4 times t n by 4, n by 2 plus multiply by 2, it becomes n plus n is 2n. You can simplify and you will get this. Right? Now, so tn by 4 will look like this. Instead of n, you put n by 4. So it will look like t n by 4 by 2 plus n by 4. So it will look like 4, 2 times t n by 4 by 2 plus n by 4 plus this 2n, right? This term I have got it from here, 4 remains here. So if you solve this, you get 8 times t n by 8 plus 4 n 2 times, that is 3n. Are you getting it? So if you write general term, let's see one more observation. So if you see, this looks like 2 power 1 t n 2 power 1 plus 1 into n. This look like 2 power 2 t n 2 power 2 plus 2 into n. This terms look like 2 power 3 t n 2 power 3 plus 3 times n. So now it will be helpful for writing the general term. So what you have to write? 2 power k. 3, 2, right? So I'm writing k. T again n 2 power k. 3, 2, 1, right? N power k plus 1, 2, 3, so on. It is k into n. Are you getting it? So your Tn, general term for Tn is this. Let's save it. Okay. Now, now let's what to? Let's assume that 2 power k is n and apply log to both sides. So when you apply log to both sides, what do you get? Log 2 power k log 2 power n. And if you know the property of log, that log a is 1, log a b power k becomes k times log ba. These are the two properties of log you should remember. So if you do that, this becomes k log 2 equals to log n. I can write n. So k becomes k dot 1. This is 1. So k equals to log n. Right? So I will use this relation in this equation, this relation also, whatever I have assumed. So let's do that. Okay, let's do that. Okay, now I'll write it again here. So t of n was 2 power k t n by 2 power k plus k into n, right? So 2 power k was n, so can I write this as n into t, n upon 2 power k was n, so n by n plus k is what? Log n into n. Make sense? Now n into this becomes t of 1 plus n log n. Make sense? Now t of 1, we have seen t of 1 is 1. When n equals to 1, t of n was 1 only. When there is a one element, I have written also, when there is a one element, the time taken by quicksort is 1 only. So if you put that back, you get n plus n log n. Now, asymptotically, what we do when such thing comes asymptotically, bigger function is dominant. Bigger function is dominant. So therefore, therefore, n log n will be a dominant. N log n will be dominant. So T of n equals to n log n. So time complexity for best and average cases n log n. So if you have any confusion here, so I'll give an example. So how if you have got something like this, right? If you have got function like n square plus n power 4, so what we do, we calculate the dominant functions, right? So the dominant function is this. So asymptotically n power 4 will be dominant. So we consider the time complexity as n power 4. We neglect this, right? So same I have done it here. In our next video, we are going to derive for same in case of worst case, right? For worst case, we are going to derive the time complexity. So if you like this video, please do like, share and subscribe. Thank you.